Hi everyone, welcome to the third video of this series of designing a newsfeed system. So in the previous video, we have discussed about a high level design of two main features of this newsfeed system is like feed publishing and one other is the newsfeed building. So in this video, we will be diving deep into the designing of each of these individual component. In this video, we will be looking into this topic feed publishing, and in the next video we will be discussing about newsfeed building. So without wasting any time, let's dive deep into the details of each of these components. So first we have is feed publishing. So what is feed publishing? So feed publishing is basically, in high level definition we can describe, is like whenever a user posts something or writes something on a social media platform or any other platform, and these things are being fed into the feed of the user's followers or the user's friends, so that they can be updated with the user's posts. So this is a high level definition of feed publishing. So let's look into a flow diagram of how a feed publishing works, and then we will discuss the individual components in details. So this is a detailed design of how a feed publishing happens. So we discussed the most of the components in the high level design, so you can have a look into it. Here we will be looking into two main components. One is the web server and another is the Fanout service. So we will be discussing about them in details, or look into in details of these individual components. One is the Fanout service, another is the web server. So web server, what is a web server? So what is the functionality of web server is like, so let's say suppose a user sends a post API request along with its authorization token to the newsfeed system, and the load balancer distributes the load as per the traffic to the particular web server. So once the web server receives the request, this post request, what it does, it has two main functionalities. One is enforce authentication. So what does it authenticate? So if you see here, the user sends a authorization token along with its content. So this authorization token is validated by the web server, so that valid users can only post in the social media platform or the particular platform. So this thing validate user with authorization token, and the other is rate limiting. So to limit the number of posts per unit time, so that the systems doesn't undergo starvation, or there is to prevent denial of service attacks, we use a rate limiting. So this is the main functionality of a web server. So now let's look into this Fanout service, what it does basically. Second important thing is Fanout service. So the main task of this Fanout service is to deliver the post to all the friends, the post request which has been made by the user. Once it is saved into the database, we feed the news feed of all the users' friends or followers with the latest post made by the user. So this is the main functionality of Fanout service. What it does is process of delivering a post to all friends. And for this we use two methods. One is the Fanout on write method, which is also called the push model, and another is the Fanout on read, which is also called the on demand or the pull model. So these are the main two methods in which we execute our Fanout service, Fanout on write and Fanout on read. So let's discuss about this in little bit of details. So what it does actually. So first we have is Fanout on write. So in this, basically what happens is the news feed is pre-computed or rather it's computed during the write time of a particular user. So basically what happens is whenever a user makes a post or writes a post to a platform, that post is immediately fed into the newsfeed cache of its users or its friends or its followers. So this is basically the newsfeed pre-computed newsfeed of users, friends or followers, you can say, is pre-computed during write time, or basically this is the user's post time, you can say. So this is the newsfeed is delivered to friends cache immediately. So the pros of this method is, let's say if we discuss the pros and cons. So the major pro, you can see that the newsfeed is already fed with the user's latest post. So whenever a particular user opens the platform or uses the application, his newsfeed is immediately populated. So there is low latency, or there is very much less delay in fetching the news feeds or the latest posts of the particular user's friends. So news feed is generated in real time and pushed to friends immediately. Another thing is, since it has already been pushed, so whenever the user uses the application, the fetching the news feed is very fast. So these are some of the pros. So the major cons for this method is, and suppose a user has many friends fetching the friend list of that particular user. Suppose a celebrity or an influencer has millions of followers. So whenever we want to feed the news feed cache of all its friends or followers, what we have to do is fetch the friend list and update the news feed cache of all those friends. So which is basically very resource intensive, and that becomes a slow process and time consuming. So this is also termed as, so let's write down and we will introduce the term. So suppose a user, or I would say an influencer or a celebrity, has many friends. So what happens is, like, fetching the friend list, updating the newsfeed cache is very resource intensive and also becomes slow process, since a large number of requests has to be handled in order to feed the cache. So becomes slow, time consuming basically. So this particular user ID or post ID of that particular user whose news feed, whose post has to be fed into the cache of all its followers or its friends. So this key, which is the post ID or user ID, becomes a very resource intensive key, or that is termed as a hotkey problem. So this is a term, you can read more about it. So the post ID or the user ID becomes a hotkey problem, since to feed the cache of its friends or in real time becomes a resource intensive job, and thus making the process slow. And another thing is, like, suppose a particular friend has not been inactive on a particular social media platform or an application. So for every time whenever his friend or a particular user posts, we have to pre-compute the news feed of that user who has been inactive, and that becomes a time consuming or a wastage of resource. So for inactive users, pre-computing news feed is time consuming or wastage of resource. So to handle these cons or the disadvantages, what we also discussed about it here, the fan out on read model. So what it says is, what happens in fan out on read model is, like, this is also termed as pull model, fan out on read. So here the news feed is generated during the read time. So whenever a user posts something, immediately the newsfeed cache of its users are not being updated. So whenever user, the friend's user, opens the application or uses the application, at that time his newsfeed is populated with the latest posts of the user, of its friends basically. So the newsfeed is generated during read time. So this is also termed as on-demand model. So the major pros of this is, as we discussed for the hotkey problem also, so for inactive users or rarely logging in users, fan out and read works better basically. So as you can see, for inactive users prefer fan out on read, and also the data is not pushed into the friends post whenever a user posts or something, so there is no hotkey problem. No hotkey problem. But the disadvantage is, like, unlike fan out on write, when a user posts and it is immediately populated to newsfeed cache, so there is a latency involved here, since the newsfeed cache is not updated with the latest user's posts or his friends or followers posts. So fetching news feed is slow since it is not pre-computed. So depending on our use case and depending on the design, what we use is we follow a hybrid approach. So what do we follow? Among the fan out on read and fan out on write, we follow a hybrid approach. So in this, there is a mix up of both fan out on read and fan out on write. And although since newsfeed retrieval needs to be very fast, so mostly we follow the push model or fan out on write for majority of the users, for major users. Suppose for celebrities or influencers, we follow the fan out on read model. Fan out on read model or the pull model. Okay, so let's now discuss the workflow of this fan out service with the help of a flow diagram, and just to give an overview of how this thing works. So this is the workflow diagram of a fan out service. So here what happens, whenever the web server sends the request to the fan out service, it fetches the friends IDs. So this is step 1. It gets the friend IDs from the graph database. So why do we use a graph database? So this is an interesting thing. So graph database is suited for like friend relationship or recommendations, and depending on it what posts each of the friends can see. So that's why we use a graph database. So you can read more about this database in details. I will post the link in the description box. Yes, so whenever the request comes to the fanout service, it gets the friends ID. After that, it gets the friends data from the user cache and the user database. So this is important, like suppose a particular user has muted a particular friend or particular follower, and also he has posted this, and also there can be a situation in which he has posted this particular content to be visible to a certain specific users. So that's why we get the information about the relation between the two friends or the two users. And after all this, when we have all this information, it gets to the fanout service, and then the request is sent to the message queue. So what we have in the message queue is we have the friends list and the new post ID basically. So we have the post ID, which is current post made by the user, and his friends list depending on his preferences. So here these are present inside the message queue. So after these are present here, so the fanout workers, what they do is, this is the 4th step, this was our 3rd step, the message queue. The fanout workers fetch the data from the message queue and store this newsfeed data in the newsfeed cache. So it extracts the data from the message queue and stores them in the newsfeed cache. So what does newsfeed cache contain? It contains the post ID and the user ID. So you can think this as a mapping table. So whenever a new post is made, it will be appended in the newsfeed table or newsfeed cache. So this is also beneficial since we are not storing the entire post and all its contents. That data can be used and the memory consumption would be very large. Thus only IDs are stored to keep the memory size small. So this also, and we can also limit the, since the chance of a person scrolling through thousands of posts is slim, so the cache miss is also very low. So this is the main content of a newsfeed cache. So now once we have seen how feed publishing happens and the current feed of the current post of the particular user is available in the friend's newsfeed cache, now we will see how a user or a particular friend's newsfeed is populated whenever he or she uses the application by looking into the newsfeed building. So in the next video, we will be discussing about newsfeed building. So thank you for watching this video. I'll see you in the next video.